Hello everyone, we're going to work some examples using the quotient rule for radicals. And written at the top of the page is the formula that we'll use. And it can go back and forth, and we also incorporate the product rule to be able to simplify these expressions. So the first example that I have for you is the square root of 32 divided by the square root of 4. I can write that as the square root of 32 over 4, which is 8. Then I use the product rule to rewrite the square root of 8 as the square root of 4 times 2, which equals square root of 4 times the square root of 2, which in turn equals 2 radical 2. And that is my simplified answer. Again, with my examples, I choose to write everything out so that it helps you to visualize and see. Or I choose to write out in as much detail as possible to allow you to see the progression. If you can already visualize some of these, for instance, the square root of 4 is simply 2. The square root of 32 is 4 radical 2. So if you're already seeing these, then that's excellent. You do not have to write everything out like I do. What I tell you though, or what I would like for you to do, is critically think about what you're doing and structure your work and try to work it the same way each time. Alright, so on to the next. And I'm not simplifying anything to begin with. I'm actually going to use the quotient rule. That's simple. Again, if you could see this before I wrote anything out, then solve it the way that you see it. Okay, for the next one, notice I have a 2 in front of this radical. Well, how I'm going to view that is simply as 1/2. And I'm going to say 1/2. See, because that 2 is in the denominator, see it's still there. There's an understood 1 right there. So I have that times the radical of 96 over 8. And 1/2 times, how many times will 8 go into 96? Go in there 1 with the 16 and 2, so radical 12. 1/2 and radical 12. My 2's cancel. All of this can be viewed as being over 1. If it helps you, put a 1 there so it balances it out visually. And I'm left with the radical 3. (72y to the 5th) over 3y to the 3rd. Okay, I'm going to look at how many times can 3 go into 72. 2, 24 times. So that equals the square root of 24. And using my exponential rules, the quotient rule, y squared. That becomes y to the 5th, or y to the 5 minus 3, which is 2. 24, I need a perfect square. Okay, and what that one will be is 4. Very good. So the square root of 4 is 2. The square root of y squared is y, and then a radical 6. And that is using this version where I combine my two radicals together to make a fraction under one radical. Let's look at another set of examples. This one I'm going to take the fraction, I'm going to break it into two radicals. So for my first example, I rewrite 12 divided by m squared as the square root of 12 over the square root of m, and then solve. And that is my simplified answer. So for the next problem, 6y squared over the square root of z to the 12th. I cannot do anything with my radical 6. The factors of 6 are not a perfect square, so I'm left with y radical 6 over z to the 6th. because z to the 12th is the same as saying z to the 6th squared, or z to the 12th, my root index is 2, alright, got a cube root here. Let's see if I can remember to write them down. Cube root of 4, well, there's nothing that I can multiply by itself that is an integer that will give me a perfect square, or that is a perfect square. 2 times 2 times 2 is 8, 1 times 1 times 1 is 1, so that remains the cube root of 4. But the cube root of 27 is 3, because 3 times 3 times 3 equals 27, which is the same as saying 3 cubed. Alright, I have 4 times the cube root of 27, x to the 4th, all of that over 8 y to the 6th. So I can rewrite that 4 like this: 4 over 1 times the cube root of 27 x to the 4th over the cube root of 8y to the 6th. So this is going to be 4 over 1 times the cube root of 27 times the cube root of x to the 4th cube root of 8 times the cube root of y to the 6th. Well, cube root of 27 is 3. Oops, let me not write that out yet. And this right here is the same as saying the cube root of x cubed times x. So I can pull out an x, and that leaves me the cube root of x over 2 y squared, because this right here is the same as saying y squared cubed. Simplify. I'm left with 6x cubed radical x. I'm sorry, that's not cubed. My root indexes, I thought I could make it through there without messing one of them up. Cube root of x over y squared. And my last one, again, you notice some of these have a prime number in there, like 4. Don't let that throw you off. Same here with 41. 41's a prime number. I cannot do anything with it. There's nothing wrong with that. And I went ahead and wrote it like this time to be able to help us. X squared 41x over 3 y to the 4th. Again, in working your problems, I want you to work the problems the way that you see them. What I ask is that you critically think and structure your work. You work the problems the same way each time. So hopefully these examples of the quotient rule to solve and simplify radical expressions has helped. Good luck on the remaining homework problems that you have.